I'm Sonia from Create Education. So I am a design and technology teacher, secondary trained, but I have taught design and technology along with computing and science in primary schools as well for a number of years. And I am a primary school governor as well currently. So I've been working with 3D printing for over 5 years for Create Education, and we work specifically with education, with schools, primary schools, secondary schools, colleges and universities. We don't sell anywhere else but into schools, but we don't just sell printers, we also support you. So our website is a whole hub of support, because there's no point you investing in this technology if you don't use it to the very, very, very best of what it's capable of and get the most out of it, because it is an investment. So it needs to be a worthwhile investment for you. So what I'm going to do today, I'm going to share my screen. If you have any questions while I'm talking, you can either save them till the end. We will do a quick Q&A at the end, or you can type them into the chat and we'll review the chat at the end as well. So I'm just going to share my screen. Bear with me 1 second. So at this point, you should all see some slides. This is us. So I'm going to start off by introducing the technology and explain how this technology works and why it's important. Then I'm going to talk through some of the curriculum benefits, some generic benefits for the primary classroom in general, including sort of cross-curricular with some examples, but really focusing on design and technology. I'm going to talk you basically through the process of 3D printing, and then explain sort of what software you can use and so on. It's not a full-on training session, this. If you take part in this project with us, with the loan printer, you will have a separate 1-hour training session with me remotely, where we'll cover the software in a lot more details and how to use the product. You'll also get a 1-hour sort of setup call with our technical support team, who will get the printer up and running with you as well. Okay, so it's all about supporting you to use this the best that you can while you've got it. Okay, so what is 3D printing? Here's a very simplified diagram of a 3D printer. Okay, so you start with a roll of material. Now, there's lots of different 3D printing technology, all using sort of different materials. The ones that we use in school are called FFF printers, fused filament fabrication. And this reel of material on the back is your filament. It's a plastic type material. So we've got various different plastics that can be used with the 3D printers. And again, we will recommend the best one to use, that's the safest, the most cost effective and the most reliable filament. And in fact, if you take part in the loan, you will be supplied with a roll of filament for the duration of the loan period as well. Okay, so you'll be supplied with the materials. So you start with a roll of filament. Depending on the 3D printer you've got, that will either be mounted on the side of the printer or inside the printer even, some of them do, or on the rear of the printer. That is then fed into the printer, and this little bit in the center here, which is represented by this little thermometer, we generally call the hot end, because what that does is it contains a heating element. The material is fed into that. It heats up the material so that the plastic melts, and it squirts it out through a very, very fine nozzle. So it's squirting out material. And what it does, the base of the printer here is the build plate or the build platform that raises up so that it almost touches the nozzle. And then the nozzle and this hot end moves around and it draws a picture with a layer, a very, very thin layer of plastic, because it's just like icing a cake. So if you've got a flat cake, you've got a piping bag full of icing, you squeeze it out through the nozzle and you move that around and you can draw a pattern with the icing. Once it's got one layer of material down, the build plate or the build platform moves down a fraction and then it draws another layer on top. And those layers build up, and every layer can be a completely unique shape, and they build up, and there's some fans on the side of your hot end blowing cool air onto the print, which cools that plastic down so it solidifies and it fuses those layers together so that you end up with a solid object. Now, the way it works by depositing like layers of material, and because every layer of material can be a unique shape, it basically means that you can make sort of anything that will fit on that build plate within the machine and the height of the machine. You know, there is a build volume that's the maximum size of your print, but you can actually make anything of any shape. There are some limitations. 3D printers don't like overhangs because there's nowhere for the melted plastic to rest on. So sometimes we have to get around that with the design or the orientation of the print, or we can put little support structures underneath that we snap off afterwards. But generally, you can create things with very complex geometries, which makes it really, really exciting. And that's sort of transforming how things are used in industry. I've got a little video to show you one in action. This puts it in context a little bit with the design process. So I am going to talk through this while we're playing this video. So just bear with me a second. Is that playing? Just going to mute that. So like with any sort of design and technology activity, the first thing you're going to do is come up with some design ideas. We recommend you do traditional sketching, get the students to come up with some ideas of what they would like to print. They can sketch them out, maybe then select the elements that they want to incorporate into their final design. That design then needs to be drawn into some 3D modeling software, and I'll talk about the software later. There's an intermediate stage where you have to do what we call slicing, which is where we chop up that design into the layers, and we apply various different print settings to that design. Okay, this video shows you saving onto an SD card, but you can save onto your network, you can save onto a USB, depending what printer you have, whether it's networked or not, depends how you transfer that file. You then insert your material into the machine. Once the material's on, it can stay in the machine until you decide you want to change color or until that reel of material runs out. And then you just, on the printer, you just literally press a print button. It's as simple as that. And this is a speeded up video, okay, just so you can see that process, okay? So this is the space rocket design. As you can see, you've got a really complex shape there, and it's all manufactured inside that little not so magic box, and then you end up with your finished design. So that's a little time-lapse video. In reality, it's much slower than that. The drawback of 3D printing, it is a very slow process, but in reality, what you're doing in primary schools, you're going to be doing little small objects that cost very little in terms of material, and they print quite quickly. And you can also print multiple designs at the same time. As long as those designs will all fit within the space of that build plate, you could print, you know, sort of maybe, you know, sort of 6 or 7 designs at the same time, depending on the size of those designs. So why should you do it? Okay, so the first thing is it's about skills, and it's about making skills, designing skills for the future, for jobs. There is an increasing demand for these skills now in many industries, okay? Additive manufacturing or 3D printing is transforming how industry makes things. It is new technology. It's been widely embedded within manufacturing companies, engineering companies, within product design, architects, in medicine. There's many industries that are using additive manufacturing now to make things for whether it's prototypes or tooling or actual, in fact, now final sort of products and parts. So this sort of touches a whole sort of range of industry. So we need students to learn these skills. Now, secondary are starting to do this more and more. But actually, if students can hit the ground running in year 7 because they've already done some in primary school, that means that the secondary schools can introduce the professional 3D modelling software to the younger students. So by the time they're leaving secondary school, those students will be proficient in the advanced software and the tools and techniques that industry require. So it's going to give them like an edge into getting those jobs. Okay, so that's the first reason why. But let's look back at education. Let's take it back down to the classroom and what you do. So first and foremost, you cannot underestimate the awe and wonder of 3D printing. I have one at home. I've had one for 5.5 years. I still find myself stopping and staring as it makes something. It's like a little magic box that produces something out of your imagination. And students, children, they are transfixed by it. So, but not only does it awe and wonder, but because it provides that sort of engagement, it also fosters creativity because it allows students to create really high quality products from their imagination that they're proud of. You're not having to simplify or oversimplify their designs because you know that in reality, they've not got the skills to actually be able to make them because the printer makes stuff with really complex shapes. So as long as they can produce that in the software and draw it, you can make it pretty much. And actually, students now are becoming more and more proficient with computers and technology and software. So they will pick up the software quite quickly as well. So that's one thing. Then if we look from a cross-curricular aspect, it actually helps with the real application of maths, science, computing and design and technology. Okay, so in maths, you're covering all the time 2D and 3D shapes, coordinates, scaling, 3D planes, you know, X, Y, and Z plane, angles, distance, transformations, measurements. Okay, you're doing that just by designing something in the 3D modeling software. In science, you can cover like properties of materials, the states of materials, environmental aspects and elements. You cover computing, because if this is physical computing, you can even code 3D printed designs. Okay, so this is a screenshot of basically it's Scratch for 3D printing. So you can do code that then produces a 3D model that you can 3D print. But obviously today we're talking specifically about design and technology, and I've got more slides about that, how this really helps you to deliver really good design and technology in primary. Okay. The third reason why is that it is a tool for the complete curriculum. Okay, you would be absolutely crazy if you invested in a 3D printer and only used it in design and technology. Okay, because actually you can use it across the curriculum. There's loads and loads of examples. I've written a 32-page guide to the primary curriculum and all the lots and lots of ideas for how you can use it in other subjects. Obviously, design and technology is where, you know, we're focusing on, and that's where sort of the biggest benefits are. But if you've got this, you've invested in the technology, by all means, use it for that engagement factor. The fourth reason why is you can actually save money, okay? Because what you can do is you can make your own sets of curriculum resources, okay, that you can use in the classroom, okay? So if you're teaching about teeth and eating and the different types of teeth, why stick with a labeled diagram, which is two-dimensional? Why not print out a model of a set of teeth, okay, which costs, you know, 50 pence in materials to print, and you've actually got a resource there that you can use. Your students can actually see the teeth, the shape of the teeth in 3 dimensions. You know, if you're doing ancient Egypt, you know, print off some pyramids with diagrams of the chambers in while you're talking about the pyramids. Print off a model of the solar system to help you with science. Print off some maths manipulatives. These cost a fortune to buy. Okay, the material cost of 3D printing is relatively low cost, so you can actually save money on investing in resources by just making your own. And then finally, design and technology. There's a lot of information on this slide. You will get access to a copy of these slides to read them in your own time, because this is just a quick sort of whistle-stop tour. But these are the 5 good reasons why we should use 3D printing in design and technology, the real sort of teaching and learning benefits. So first of all, it helps pupils to make high quality projects and parts with complex geometries. Pupils' ideas are not simplified by the limitation of the tools that they have access to in school or by their own physical making skills. Okay. It's easy to iterate. So the whole sort of design process is about coming up with an idea, producing a design, making a prototype, testing it, evaluating it, and then developing that design and trying to improve it and make it better. Well, it's really hard to do that process and keep doing sort of the improvements to designs within the time you've got in school, because if you're doing a project, generally, you've not got time for your students to make something twice. They've only have time to design and make once. And yes, you can evaluate it and say, oh, well, it could be improved by doing this, or it could be improved by doing that. Well, if you're 3D printing, what you can do is go and tweak their model design. And it might only take 10 minutes to go into their original design and, you know, make that, that little part a bit wider so it's easier to grip. And they just change one tiny bit of their design, and then you can 3D print it. And it's not taking, you know, sort of hours and hours for them to remake anything, because the printer's doing the physical making for you. So it's easy to produce and improve designs. Your students then are developing valuable skills required for future careers in both engineering and advanced manufacturing and other industries that use this technology, you know, product design and you know, sort of many other things. And then the final benefit is, after the initial cost of investing in a 3D printer, the ongoing running costs and the material costs are very, very low. Okay, materials are relatively low cost. You don't use much, especially if you're just making small stuff. And there's no wastage, or very, very little wastage. It's not like most things when you make, you'll start with a big block of material and then you sort of cut away of it and there's loads of wastage that just goes in the bin. There isn't really, you're only using the material that you need to make that item. Okay, so that's the reason why. The next part, I want to very, very quickly explain sort of how. So what is the process? Just to simplify this process, we can simplify it into 3 parts. The first part is 3D modeling. You cannot make something without a 3D model in the first place. Okay, and there's different ways of getting a 3D model, which I'll just outline very briefly on the next slide. However, once you've got a 3D model, what you need to do then is you need to do a process called slicing. We use some specific slicing software for this. The software is free, and there's different types of slicing software. Each manufacturer uses their own preferred software. Okay, and that will come. You'll usually get a download when you buy a 3D printer. You know, there'll be a download for the software. You just download the software and install it onto your network, or it may even be cloud-based software, depending on the manufacturer. Okay, but in that software, what you do is you import, or you open up your 3D model, and you have a representation in the middle of that software of your 3D printer. You can resize that in the software. You can move it around. So you could, you know, this one's a robot design. Well, if every student was designing a little robot, you might have room there to put 6 different designs on and print 6 at the same time. Okay, so you can move them around, reposition them, resize them, but then you can put in some slicing settings, which basically tells the printer how thick to print each layer, and whether to print it hollow or solid or somewhere in between. You can alter things like print speed, and there's a number of different settings in there. Okay, and I will cover that in the online sort of training if you take part in this pilot. Okay, so you have this software. Once you've put all your print settings in and you've got everything arranged on the build plate there in the software, you simply slice that design, save it either to your network, a USB or an SD card, depending on your 3D printer, and then you print that file on your printer. And it is literally as easy as pressing the print button on your printer. It's simpler to start a print on your 3D printer than it is to set a print off to your, you know, sort of your school printer on paper. Okay, so that's the process. So let's start with step 1, 3D modeling. And we're not going to do any of this today, but really I just want to make you aware that there are different ways to get a 3D model. The first thing you can do is download an existing 3D model. And what I've done is I've put some links in these slides to a couple of websites. Thingiverse is the world's largest free 3D model sharing website. There are thousands upon thousands upon thousands of designs that people have created, and they've uploaded and shared for free. So you can download them. All the licenses on Thingiverse are free for education use. Some of them are restricted, so you can't start, you know, printing things to sell, because commercial use might be limited. You do need to check the license model on those files. But certainly for use in a classroom, you can download any of the files that you find on Thingiverse. Imagine is another one by a different manufacturer. So they're good places to look for ideas for things that you could make, but you can also download examples as well. So if you were doing like a little tea light project, for example, I'll show you some pictures later on. What you can do is go on to Thingiverse, to search for tea light, and it will come up with hundreds of different designs. So you might want to download and print 2 or 3 of them so that you can use them and pass them around, and you give the students some ideas as a starting point of what they could potentially sort of design. The second thing you can do is extrude a 3D model from a 2D image. So you can actually, with the very, very young students, key stage 1, lower key stage 2, even reception, you can start with a 2D image. Now, whether that's hand drawn or whether that is a 2D, you know, in some 2D sort of painting software or some 2D design software, you can actually design in 2D and you can extrude into 3D. And I'll show you some examples of that later on. What you really want to do, though, is get your students designing in 3D using the CAD, computer-aided design software. Okay, and the next slide, I'm going to show you some potential software that you could use. And finally, if you had another piece of technology, which is a 3D scanner, you can actually scan 3D objects. So you could get your students making things in clay or plasticine or, you know, or other materials. You can make a model, pop it on a little turntable scanner, and that will then make a 3D scan of that model that you can then 3D print. So that's how you do it. The most common one, and the one you should be aiming for, is actually getting the students doing that design work themselves, number 3. So how do I do that then? What software do I use? That leads me nicely onto the next slide. First of all, never pay for 3D modeling software. You can do, but you don't have to, because there's some brilliant free software out there. The number 1 choice, just purely because it's simple, it's designed for schools and it's designed for beginners and young people to use, is Tinkercad. And we will be recommending that you use Tinkercad if you take part in this pilot. And indeed, the training, the 1-hour training that I do online, I will be introducing you to that software and showing you how to use it. There are some other alternatives. There's one called 3D Slash. It's very Minecrafty. It starts with a big chunk of material, and the students use hammers and pickaxes to sort of chip away at the material and knock blocks out. Really good for very young students, maybe in sort of year 2 or year 3, just to get them into doing some 3D modeling. But I wouldn't use it with the older students. It's a little bit too simplistic. Tinkercad's the way to go. There is a new kid on the block. It was in beta for testing, so you can get a teacher account for testing and get full access to this. I'm not quite sure if it's come out of beta yet, but this is SolidWorks. Now, SolidWorks produce professional 3D modeling software used in industry. So do Autodesk, that have created Tinkercad. And in order to get, and they're 2 big rivals. So in industry, you will either use Autodesk software or you will use SolidWorks. Autodesk many years ago invested in education, and they developed Tinkercad, which is amazing, to try and get people to learn how to use the software. But also there's really good progression then from Tinkercad into Fusion 360, which is their professional 3D modeling software. And a lot of secondary schools are starting to use Fusion 360. So that's why Tinkercad's a really good option. However, SolidWorks suddenly realized they were missing a trick. So they have developed their own education software. It's called SolidWorks App for Kids. I've not spent a huge amount of time on it, but it does look quite promising. It does look quite nice. It's a suite of different apps. It's worth having a look at. But again, we're not going to be providing training on this for the course of the pilot, because Tinkercad is well established and it's got all the support that you need within the software to learn it and to teach it. So for now, we're going to use Tinkercad, but they're all worth having a look at. This is Tinkercad. I've just popped the URL there. What you need to do is register for this. It's completely web-based. In fact, what I should say is all 3 of these pieces of software are web-based. So you don't need to download anything. You don't need to install anything. You just have to go onto the website and log in. And obviously your students will need to have accounts. I'm only going to, at this point, talk about Tinkercad. Tinkercad, if you register, so if you go to join now on their website, register for an educator account. And what you will get then is you'll get another menu bar on the top called classes. And that helps you to set up and manage your own class and your student accounts. The teach section of the website tells you exactly how to do that. And there's lots and lots of information, articles, template letters to parents, all sorts of things in the teach section. If you want to learn Tinkercad, they've got a whole section dedicated to learning it, with lots and lots of self-paced tutorials, lessons and projects. And I'm going to recommend a couple of those later on. Okay, so that's Tinkercad. So where do you start? How do you embed this into the curriculum? What I want to do now is introduce you to some ideas for projects and how you sort of embed and develop skills. Okay, so the next slide is a little bit of an overview of a skills progression. Okay, so the idea is with foundation stage and key stage 1, there are a couple of options. You can start with the 2D to 3D process, and that is a really, really good starting point. If you have access, this is the only paid piece of software I'm going to mention, and the only reason I'm mentioning it is I know that a lot of primary schools already have this software. It's something called Purple Mash. If you don't have it, just ignore what I'm about to say. If you do have it, within Purple Mash, there's something called To Design and Make, and you can use it with your really, really young children, reception, year 1s, and you can actually export a 3D model of their design from that. It's the only piece of software I have found that is simple enough for reception and year 1. Okay, for everybody else, I would stick to this 2D to 3D process, and I'll show you some examples of that on the next slide. Okay, so we can do that with pen and paper, or pencil and paper, or glue and pieces of paper, as I'm about to show you on the next slide. Moving on then to lower key stage 2, so to progress those skills, you can carry on with 2D to 3D, but what you could do is do some 2D drawing using some software. By the time students are in year 2, certainly the back end of year 2 and year 3, they should have developed some sort of fine motor skills, really, and they should have developed some basic skills in using a computer. So at that point, you can introduce something like Paintbrush, you know, the Microsoft Paint, which comes free with your Microsoft Windows, or there's some online software called Paints, which is free, and that's just paint with a Z on the end.com. Some schools have like a 2D design software or some other paint software. So you can use any of that. You can draw something in 2D and you can convert that to a 3D model. With year 2, sort of end of year 2 and year 3, you can also use 3D Slash and the Tinkercad Scribble tool. But then by the time you're getting in towards the end of year 4, and certainly year 5 and 6, that's when you can introduce proper 3D modeling. And that's where I would recommend Tinkercad. If you are doing 3D printing in computing, you can use Tinkercad blocks and another piece of software called Beetle Blocks, and you can code 3D prints. But I'm not going to focus on that today because we're just focusing on design and technology. But that is an example skills progression. Let me show you what that might look like. Okay, so here's some examples of some things that you can do with the paper, 2D to 3D. Okay, so this dinosaur, this is where in reception they've been talking about 2D shapes, and there's lots of shapes cut up, and the students, all they've done is they have selected shapes and they've glued them. So we're practicing some gluing skills. The students could also practice their cutting skills with a pair of scissors. So you could give them some pieces of black paper. They could cut up the shapes themselves and glue them on. So you can practice cutting and gluing, okay, which are all great skills for design and technology, especially at sort of with 4 and 5 year olds. Okay, so cutting and gluing onto a piece of paper. We can take a picture of that and we can slice it in the software and 3D print. Okay, so the students can see their designs being 3D printed. Okay, we can also use Sharpie markers. So we could provide a template. So students could, this is where they were looking at the built environment. It was actually combined with a little bit of a photography project using the iPads around school, and they were looking at lines and shapes in the sort of the built environment versus the natural environment, and then they had to take a theme from what they've looked at and come up with some design ideas. So that's an example where you could give the students a Sharpie marker and they could draw onto a template, and you can 3D print a product. Handwriting is another good example of the 2D to 3D. So that's really good for young students. I've only got about 5 minutes, so I'm going to really skip through some of this. This is using some software, just a couple of little ideas there. This is the 2 design and make software, Purple Mash I was talking about. How to do this, there's a link on this page. Only do that if you've got the software already. Okay, I'm not sort of saying that you have to invest in the software at all, but if you've got it, you may as well use it. Lower Key Stage 2, Tinkercad has a Scribble tool in. These are some examples of things that have been done with 3D slash, sort of chopping away blocks. Then progressing into sort of Tinkercad, you could start with a template. You could actually pre-draw something and then get your students to draw something on top. So there's just a little example for you. The Tinkercad then has some starters and some tutorials to help you to learn. These are really good ones for 3D printing. So you could start with a simple key ring, and then you could progress to making chocolate molds. As well, you could actually combine this with a bit of food technology. So you could make some cookie cutters, or you could make some chocolate molds, and then you can then make some biscuits, or you make some chocolates by using what you have 3D printed. Okay, so there's some examples. You can access them from within the Tinkercad Learn section. And then finally, what you'd really like to do is get onto independent designing. And there's a couple of little project ideas here with some links. Great for year 6 is the little phone stand project. It starts off with a tutorial. Everyone designs this little turtle. But then they are set a design and make task to design and make their own phone stand. So they need to, I can give them the measurements of your phone, or they have to go and measure someone's phone at home for homework, or if they've got phones, because they're nearing the end of year 6, they can measure their own phone in its casing. And then they have to get the dimensions of the slot right so that the phone will slot in, and then they can design the actual stand. So the project is there with all the resources. You can also design for a purpose. So this assistive device project's a really nice one, example of that, where you could design little devices to help people. Some other project ideas. So if you're doing structures and you're still doing sort of bridge building and stuff like that with straws, you could design little connectors that are 3D printed. You can design obviously decorative stuff, game pieces, pen holders, things like that. The tea lights one, there's a couple of examples of tea lights. So you can design nice decorative stuff, products. Mechanisms, combining with a mechanisms project is a really great use of a 3D printing. This one on the left is a teaching board, and you can download these files from Thingiverse, and you can make one of these and use it as a classroom resource to teach mechanisms. But then you could get the students designing a mechanisms project, but they could be designing the cams and the little handle, the turny handle. You could also get them to design the things that go on the top of the followers. But if you're clever, you could get them to design them as pen toppers or pencil toppers. And if you use the pencils as the followers for your cam project, okay, you've got a nice little 3D printed project, but at the end of it, your students can take the pencils away, or they can take the toppers away, and they've got something that they can keep. Or you could print duplicates so that they have one for their cam toy and they get one to take home. So that's a really nice little project idea. Lots more there. I'm coming towards the end of our time because I want to leave time at the end for some questions. How do we support you? We've got some education guides here. So there's a classroom management guide, there's a primary curriculum guide, a computer curriculum, guide, lots of examples in there. We've also got a funding guide as well to help you to come up with some ideas for fundraising. You can download all of these from this link. We've also got a buyer's guide. So don't rush into choosing a 3D printer. Let us help and support you. But if you want to learn a little bit more about the technology and some of the features, because there's lots of features on 3D printers that you're never ever going to use in a primary school. You don't want to pay for something for these features if you're never going to use them. Okay, but the important considerations are on this slide. These are the things you need to think about. We can help and support and advise you on this. Absolutely. Okay, but you might want to, if you want to read up about these and understand what do we mean by single extrusion, dual extrusion, open filament system, you can download this guide and it'll explain a lot of these things to you so that you understand the terminology and the technology a little bit more. Okay. We're here to support. Take a look at our website, lots of things on there, lots of free resources. We've got a blog which has lots of different case studies of schools that are sharing what they've been doing with 3D printing. Not that many for primary because it's still sort of, there's not many primary schools doing it at the moment. But hopefully that blog will build over time as more schools share with us what they're doing. But if you go to the primary section of our website, there's lots of information and resources. Yeah, next steps. Once you get a copy of this presentation, I would love it if you could spend 5 minutes and fill in the feedback form for me. That just helps me to make sure that I'm communicating the right messages and answering questions and so on. We do have a teacher group that you can log on to and connect with other teachers. Not many people on that at the moment. So the more people join, the more teachers that you can connect with. And also then I'm just going to feed back. I'm going to hand back over to Tony in a minute. You can take part in this pilot program that we are running from January, free of charge. Okay. So if you're interested in that program, Tony from Data is going to talk a little bit more about that. Okay. And at any point, speak to us for any advice or support.